What about for the one that they don't have the same degree? What do we do? Okay, so let's apply the same, the technique that we do from the above first. Divide every term by the highest power in the denominator. So which one is the highest power? The highest power in the denominator is x squared. So I'm gonna divide every single term by x squared. So I have 2x over x squared plus 5 over x squared, and then over 3x squared over x squared plus 1 over x squared. And this will give us, when we simplify limit of x approaching to positive infinity, we have 2 over x plus 5 over x squared over 3 plus 1 over x squared. Okay, now what happened? So when x approaching to infinity, if I'm putting a huge number right here, this is most likely a 0. If I put an infinity value right here, I have a constant divide, a huge number, this is most likely 0. Okay, similarly for the denominator, when I put the huge number right here, this most likely go to 0. Okay, so every term is go to 0 except the 3, but the numerator is 0. So 0 over 3 is actually getting 0. Okay, so this has happened because, why is happened like this? Because the numerator, even though the x approaching to infinity, the infinity on the numerator, the value on the numerator is not as big as the value in the denominator. Okay, then the limit will approaching to 0. Because you have a smaller value divide a huge value, you're gonna have the limit approaching to 0. And that will telling you what? If you have the numerator, the degree on the numerator less than the degree of the denominator, then it's pretty much equal to 0. For example, if I have limit of x approaching to negative infinity, and then I have 2x squared plus 5x plus 1, and the denominator is 4x4 plus 2x minus 3, something like that. So we can see the numerator have the degree less than the denominator, then this actually 0. And the horizontal asymptote is y equal to 0. So the end behavior of this when x approaching to infinity will be 0. And when x approaching to positive infinity is also 0. So this gonna be happen to the function that even though you have the numerator is polynomial and the denominator is something is not polynomial, right? But as long as you have the numerator, that is the big number, when limit of x approaching to infinity, the numerator is a big number, but the denominator is super big, bigger than the numerator. Okay, it's super big, then this is gonna be 0. Okay, so what did that mean? So for example, if I have limit of x approaching to infinity of x over e to the power x. Okay, so which one will be the one that grow faster, or which one is the one that getting bigger when x approaching to infinity? So let's say x approaching to 100. My numerator is 100, right? If this is 100, my numerator is 100, and then my denominator is e to the power 100. Which one will be big? So on the numerator is 100 is big, but how about the denominator? What is e to the power 100? E to the power 100 is actually, it's going to be to the power 43. It's huge, okay? This is huge. So it means the numerator is growing big, but the denominator is even bigger. Then the limit of this will be 0, okay? Okay, so the next one for part B, yes, they have the same degree, okay? So it means the growth rate is the same, so we have the ratio of the function, which is 2/3. So the limit of x approaching positive infinity of this will be equal to 2/3. How about this? So what about if you have the degree on the numerator is bigger than the denominator? So when I put in a huge number to the numerator will be super big. and the denominator will be big, but not as big as the numerator. So you have a huge number, like 1 million, and you divide 10. What happened? You still have a very huge number, right? So you still have the big number. So, and let's apply the idea of divide every term by a highest power and to see, kind of proving our result is true. Let's see, well, limit of x approaching to infinity. So we have 3x cubed. The highest term in the denominator is x squared. So we divide that by x squared. We have 5 over x squared over x squared over x squared plus 1 over x squared. Simplify this, we have limit of x approaching to infinity, 3x plus 5 over x squared, divide 1 plus 1 over x squared. Okay, so at x getting huge, this getting huge. This pretty much 0. This pretty much 0. Okay, so when x is approaching a huge number like 1 million, then we're gonna have 3 million. If x is 1 trillion, then we have 3 trillion. So the function is keep growing without bound. So we're gonna have positive infinity. If this is limit of x approaching to negative infinity, then what happened? Then we have this is 0, this is 0. But when you have 3 times negative 100 million, then you're going to have negative 100 million, right? So you're getting super small. So which means you're going to have negative infinity, okay? Super big, super big negative value, then you have negative infinity, okay? So that generate down to if you have a rational function when your limit approaching to negative infinity or positive infinity, and the numerator is super big, the denominator is big, then the sign will be depend. Okay, then it's pretty much go to infinity. But if negative infinity or positive infinity, it will be depend on the sign of the power. So that means if you have a super big number divide a big number, then you may have a positive infinity or negative infinity, depend on the situation. Okay. Now let's take a look at this one. So this one have the radical, but the inside is also a polynomial over the polynomial, and they have the same degree. So when you see the limit of something like this, we can bring the square root out, so to the power 3, and limit of x approaching to negative infinity, 2x squared minus 3 over x squared plus 1. This is the property of the limit. Okay, so let's go back to this one more time. So when you go back to section 2.3, you will see that there's a root property. So if you have a limit of a root, you can bring the root out and then just check the limit of inside. And then the result of whatever inside will be raised to that root. Okay, so let's get back to our section. So it means I can bring the root outside the limit and then I integrate the inside. This one we will have the same degree. So it's going to be equal to the ratio of that leading term. So it's going to be 2 over 1. So which is q root of 2. So the horizontal asymptote of this function will be q root of 2. Okay, now one more. So in this one, the numerator have the radical, the denominator doesn't. Then we won't be able to bring that outside like this one anymore. No more limit will be applied. But if you look at the leading term of the numerator, this is q root x to the power 2, right? So we focus on the leading term. If we take the q root of x squared, square root of 3x squared, then we're going to have square root of 3 times x. Okay, we don't need the absolute value because our x is approaching to positive infinity. Also, okay, so it's got q root times x. So if you have q root times x and divide x, this will give you the horizontal asymptote will be square root of 3. So the answer will be square root of 3. However, be careful on this type of problem when you have the square root, okay? When you have a square root, then you will have to consider when x approaching to negative infinity. That's going to be something different, right? Square root of x squared minus 1 over x plus 3. Okay, so if that is a negative infinity, then that's going to be different because when you putting the negative infinity when you have the square, then it's going to become positive. Because actually, when you take the square root of x squared, you should have an absolute value. So this should be an absolute value. And when x approaching to positive infinity, this is positive. That's why we have square root of 3. But when x approaching to negative infinity, then that's gonna be different, right? You're gonna have square root of 3 times absolute of x over x. This will give you the negative infinity become positive, but this will be negative. So your answer will be negative root 3. Okay, so we're gonna double check with the decimal to make you confirm the answer. So if you look at the decimal, I type the function into the decimal, and then you can see when x approaching to positive infinity, the y value keep getting like 1.7, 1.63, 1.64, and root 3 is about 1.73. Okay, similar on the left side, if you go to the left, the x value, the x value is getting like negative 1.7 something, right? It's really close to that. And this is negative 1.73. Okay, so that match your answer. And that is the end behavior. So it means this problem, you will have two horizontal asymptotes. Y equal 1.73 or y equal root 3 and negative root 3 will be your horizontal asymptote. Okay, one function can have two horizontal asymptotes.